If you were suddenly exposed to space without a suit, you would not explode. You would not freeze solid in 1 second. And for a brief moment, you would still be alive. That is the first shock. Because almost everything people imagine about naked exposure to space is wrong in the wrong direction. The reality is not less dangerous, it is more disturbing. Because space does not kill you in one cinematic instant. It lets your body begin to fail, step by step, quietly, system by system. And for a few seconds, you would be there to feel it. Imagine the scene clearly. You are outside a spacecraft. No warning. No time to prepare. No suit between your skin and the vacuum. One moment, you are protected. The next, there is nothing between your body and space. No air, no pressure, no sound, no warmth, no barrier at all. At first, the silence would be the strangest part. On Earth, danger usually arrives with noise. A crash, a scream, wind, impact. In space, there is none of that. The moment is silent, completely silent. Your body enters crisis, but the universe around you says nothing. And in that silence, the first decision becomes everything. If you panic and hold your breath, you may tear your lungs apart. That sounds dramatic, but it follows basic physics. Inside your chest is air compressed for life on Earth. Outside your body, in space, there is almost no pressure at all. So if you trap that air inside you, it will expand. Violently. Your lungs are not built for that difference. So the first rule of sudden vacuum exposure is simple. Exhale. Do not try to save the air. Do not hold on to it. Let it go. Because the air you keep may do more damage than the air you lose. That is one of the cruelest things about space. Your survival begins by giving up the very thing your body depends on. Now imagine you exhale. Your last full breath leaves you. For one instant, nothing seems to happen. Your skin is still intact. Your eyes still see. Your heart is still beating. Your mind still says, move, get back inside, grab something, do something. And this is exactly why the moment is so deceptive. Because the human body can continue functioning for a few seconds, even when the conditions for life have already disappeared. There is always a delay, a terrible, brief delay, between the environment becoming lethal and the body fully understanding that it has already lost. That delay is where the horror lives, because you are conscious inside it. The pressure around you has collapsed now, not lowered, collapsed. And pressure is one of those things we almost never think about until it is gone. On Earth, the atmosphere presses on you all the time, every second of your life. It presses on your skin, your eyes, your blood vessels, your lungs. Your entire body is built in partnership with that pressure. You do not feel it because it is normal. It is constant. It is the invisible weight your biology expects. Space takes it away instantly. And the moment it does, the liquids near the surface of your body begin to behave differently. Not all of your blood suddenly boils. That part is often exaggerated. Your blood is protected by the pressure inside your circulatory system. But exposed moisture, that is another story. The saliva in your mouth, the moisture on your tongue, the wet surfaces of your eyes, they begin to boil. Not because they are hot, but because the boiling point has fallen. This is one of the strangest truths in all of space medicine. In vacuum, liquid can begin to boil at body temperature. Not with steam rising like a pot on a stove, but with rapid vapor formation, a silent instability, a loss of physical balance at the surface of the body. This process has a name, ebullition, and it is one of the first signs that space is not merely empty, it is biologically hostile. Your body begins to swell, not explode, not burst open, but swell. As pressure leaves the environment, gases and fluids in your tissues expand. Your skin stretches, your face puffs, your hands and limbs enlarge. You may increase in volume dramatically. Some estimates suggest the body can swell to roughly twice its normal size without the skin rupturing. That sounds impossible, until you remember how strong skin really is. Skin is not fragile. It is one of the toughest structures the body has. It can hold shape longer than comfort, longer than your muscles, longer than your thoughts. So for a few horrible seconds, your body remains physically intact, while everything inside it begins drifting away from normal. At the same time, another countdown is underway. Oxygen. This is the real clock. Not cold, not swelling, not boiling saliva. Oxygen. Your blood is still moving, but it is no longer being refreshed. You exhaled. There is no atmosphere to breathe, no pressure to draw breath from, no second chance coming from the environment. What remains in your blood is all you have, and your brain consumes it fast. The brain is greedy. It has to be. It runs everything. It monitors motion, balance, memory, fear, coordination, decision, awareness, and it cannot tolerate interruption for long. So, as oxygen levels begin to fall, the brain starts shutting down functions in order of importance. Not all at once, gradually. And that is why the experience would likely feel so strange, because you would not instantly feel like you were dying. You would feel like something was becoming wrong with reality. Your vision might blur first, or narrow. This is often described as tunnel vision. The edges darken, contrast weakens. The world seems farther away, as if space itself were dimming, even though the sunlight has not changed. Then comes mental slowing. Thought becomes heavier. You try to issue commands to your body, and they feel delayed. You try to focus on the hatch, on your hands, on direction, but concentration slips. The mind that usually feels immediate, sharp, self-owned, starts lagging behind experience. This is hypoxia. And what makes hypoxia dangerous is not only what it does, it is what it hides. Because severe oxygen loss does not always feel like panic. Sometimes it feels like detachment, a drifting calm, a vague confusion, a dangerous softness. People in high-altitude aviation accidents have described this kind of mental fading. They do not always scream. They do not always fight hard enough. Because the brain losing oxygen is not a good judge of its own decline. That is a frightening idea. To be dying, while becoming less able to notice that you are dying. Now imagine trying to save yourself in that state. You reach for something, a rail, a tether, the edge of a hatch. But in space, motion obeys different rules. On Earth, if you trip, you fall. If you run, your feet grip something. If you reach, your body anchors itself without your having to think much about it. In space, there is no automatic anchor. If you are drifting away from the spacecraft, even slightly, you continue drifting. If your body begins to rotate, it keeps rotating. There is no air to slow you down, no ground to stabilize you, no friction to help correct the mistake. And so the loss of oxygen combines with the loss of orientation, a dangerous partnership. Because your body is now failing inside an environment that gives you no intuitive help at all. There is no up, no down, no fixed horizon, only the spacecraft, if you can still see it clearly. Only darkness, if you cannot. And this is where the emotional reality of exposure to space becomes different from anything on Earth. On Earth, even in danger, the world still feels familiar. You know what direction means. You know what a body feels like. You know how heat, motion, breathing, and gravity are supposed to work. In space, all of that begins to unravel together. You are suffocating. swelling, disoriented, silent, untethered, and every one of those things makes the others harder to survive. Now let's talk about temperature, because this is another place where people imagine the wrong kind of death. Most people think space would freeze you instantly, that your body would become ice in moments. But freezing requires efficient heat transfer, and heat transfer in space is strange. There is no air around you to carry heat away quickly, so you do not instantly freeze just because you are in vacuum. Instead, you lose heat primarily through radiation. That is slower, more indifferent, less dramatic. But exposure to space still creates brutal temperature extremes. Why? Because of sunlight. In orbit or open space, there is no atmosphere to soften the sun's energy. No clouds, no scattering, no protective blue sky. If direct sunlight strikes your skin, it strikes hard. The side of your body facing the sun can become intensely hot. The side facing shadow can become deeply cold at the same time. This is not like being in winter, not like standing next to a fire, not like desert heat or Arctic cold. It is asymmetric thermal violence. One side baked, one side starved of heat, and your body, already losing oxygen and pressure stability, has no meaningful ability to regulate it. Still, temperature is not what kills you first. That matters, because the biggest threats in sudden vacuum exposure are immediate pressure loss and oxygen deprivation. The body has some thermal inertia. It takes time to actually cool or heat in depth, but it does not take long at all for the brain to run out of usable oxygen. That is why the timeline is so short. Within perhaps 10 seconds, serious cognitive impairment begins. Soon after that, consciousness is in danger. Some estimates suggest a person may remain usefully conscious for roughly 10 to 15 seconds after sudden decompression into vacuum. Usefully conscious. That phrase matters. It does not mean perfectly fine. It means capable of purposeful action. And even that window is brief. Much briefer than movies teach people to expect. Imagine that. 10 seconds. A handful of thoughts. A few confused movements. A narrowing world. And then darkness. No dramatic scream required. No visible monster. Just biology reaching its limit. And when you lose consciousness, the story does not end immediately. Your heart may still beat for a short while. Your body may still have electrical activity. Cells do not all die in the same instant. Life is not a light switch. It is a network, a collapsing network. And space collapses it by removing the conditions under which that network can continue. Not by attacking the body with claws or fire, but by taking away air, pressure, stability, and time. That is what makes vacuum exposure so unsettling. It does not feel like being destroyed by something. It feels like being abandoned by everything that usually keeps you alive. Now, strangely enough, brief vacuum exposure is not always automatically fatal if rescue is immediate. That sounds almost impossible, but we know it from both animal data and accidental human exposure events. There have been moments in aerospace testing and decompression accidents where people were exposed to near vacuum for a short time and survived. Not unharmed, but alive. In one often cited accident during vacuum chamber testing, a technician reportedly lost consciousness after exposure and later described the last sensation before blacking out as the saliva on his tongue beginning to boil. That detail is unforgettable, not because it is dramatic, but because it is so intimate, so close. Not the stars, not the void, just the inside of your own mouth becoming physically wrong. That is space. Not always grand, sometimes horrifying in the smallest possible way. And this is only the first phase, because so far we are still talking about the opening seconds, the threshold, the moment when the body first realizes it has been placed somewhere it cannot belong. We have not yet gone deeper into what happens inside circulation, inside the lungs, inside the nervous system, when consciousness is gone, but physical damage continues. We have not talked about the eyes, or decompression injury, or what rapid rescue can and cannot reverse. We have not talked about why not exploding is not comforting at all. Because the truth is more precise than that, more clinical, more merciless. You would not explode. You would not instantly freeze. You would not burst into blood. You would simply begin to fail, in a place so silent and so empty that your death would have no sound at all. And that may be worse, because in the first seconds of naked exposure to space, the body does not die theatrically. It dies accurately. In the next part, we go beneath the surface of the experience, into the organs, the blood, the eyes, the fading brain, and the thin line between a survivable rescue and irreversible damage. By now, you are no longer dealing with the shock of exposure. The shock has already happened. What remains is the body trying to continue inside conditions it was never built to survive. And this is where the experience becomes even stranger, because once consciousness begins to fade, people often imagine that the danger is over, that after blackout, the rest would be quick, simple. But the body does not stop just because the mind lets go. The damage continues, quietly, precisely, and in some ways, more brutally than before. Let's begin with the lungs, because the lungs are where one of the most important differences is made. Whether you survive even briefly or suffer immediate catastrophic injury depends on what happened in the first second. If you exhaled, you gave yourself the only chance the body has in vacuum. If you did not, if you panicked and trapped air inside your chest, then the expanding gas could rupture delicate tissues inside the lungs. The alveoli, the tiny air sacs where oxygen normally passes into the blood, are built for pressure differences within a narrow range. On Earth, that range feels natural, safe, invisible. But in vacuum, the pressure outside the lungs falls so fast that the gas inside them tries to expand all at once. And expansion is not gentle. It can tear tissue. It can force air into places it should never enter. Into the chest cavity, into blood vessels, even into the circulation itself. This is called pulmonary barotrauma, and it can be fatal very quickly. Not because space is crushing you, but because your own trapped breath becomes a weapon inside your body. That is why astronauts and aerospace physicians emphasize the same rule again and again. Do not hold your breath. Exhale. It sounds almost absurd, as if survival in space begins with surrender. But in a way, it does. Now imagine you did exhale. You avoided the worst lung rupture. Even then, your lungs are no longer helping you. They are empty, collapsed into irrelevance. There is no air to draw in, no pressure to fill them, no oxygen waiting in the next breath. Breathing as a motion may still happen for a second or two, the chest rising, muscles trying, but functionally, breathing is over, and the bloodstream feels that loss immediately. Your blood does not become useless all at once. For a few moments, oxygen still circulates, a final reserve, a final delivery. But every heartbeat now is spending something that cannot be replaced. That makes circulation feel almost tragic. The heart keeps doing its job. The vessels keep carrying blood. The system keeps trying to support the organs. But there is nothing new coming in. No fresh oxygen. No recovery. Only decline. And the organ that notices first is the brain. The brain always notices first, because it has the highest demands and the lowest tolerance for interruption. A healthy human brain lives on a narrow margin. It needs constant fuel, constant oxygen. Take that away, and the change begins within seconds. You would not think clearly enough to narrate what was happening. That part is important. People often imagine they would analyze it, observe it, remain mentally present inside the event. But real oxygen loss does not allow that for long. It strips away the ability to assess yourself accurately. At first, you may still have a few clean thoughts, a task, a direction, a target, the hatch, the tether, the handle. But those thoughts begin to fragment. Your attention slips. Your short-term memory fails to hold on. You may forget what you were reaching for even as you reach for it. That is one of the cruelest things about hypoxia. It doesn't just weaken you. It separates you from the knowledge that you are weakening. Your reaction time lengthens. Coordination degrades. Fine motor control disappears. The body that on Earth can type, turn a latch, aim a tool, make a precise movement, now struggles to perform even simple action. Not because your muscles are gone, but because the command system is starving. And then vision changes more dramatically. This is not just blur, it is collapse of visual usefulness. Peripheral vision narrows, contrast falls, brightness becomes harder to interpret. You may see light, but not clearly. Shapes remain, then dissolve. Space itself begins to feel both too large and too flat. This happens because the retina and visual cortex are also oxygen hungry. They fail early, and when they fail, the world becomes less usable long before it fully disappears. That matters, because rescue and vacuum is not only about staying alive, it is about whether you can still do anything to save yourself. And the answer becomes no, very quickly. Now let's talk about the face and the eyes, because these are often imagined as dramatic points of injury. People think the eyes would pop out, that the body would split open under pressure loss. That is not what happens. Again, the truth is more controlled than the myth. The tissues around the eyes swell. The moisture on the surface begins to boil. The eyes become irritated, unstable, painful. Vision may blur further not only because of hypoxia, but because the environment around the eye is physically wrong. Tears cannot behave normally. The surface dries and boils at once. The eyelids do what they can, but they are protecting against conditions no mammal evolved to face. Your tongue and mouth would feel the same instability. If you were conscious long enough to notice it, the saliva would fizz and boil. Not from heat, not because you are burning, but because liquid exposed to vacuum cannot remain calm. That detail matters because it reminds us of something important. Vacuum injury is not a single injury. It is dozens of small physical wrongnesses happening at once. The body does not understand how to organize around them. Skin swelling, drying surfaces, boiling moisture, fading consciousness, misfiring coordination. No breath, no pressure, no sound, no time. And yet, the circulatory system keeps moving for a little while. That means some injuries remain limited if rescue happens fast enough. This is why brief exposure is not always irreversible. If a person is returned to pressure quickly, oxygen restored quickly, circulation supported quickly, some of the early damage can be reversed. The body can recover from more than intuition suggests. But timing is everything, because there is a threshold, and it comes closer with every second. After roughly 10 to 15 seconds, useful consciousness is likely gone. After longer exposure, the chances of severe injury rise sharply. Cardiac rhythm may destabilize. Brain damage risk climbs. Cells deprived too long do not simply restart when air returns. They die, and when enough of them die, recovery becomes impossible. This is why rescue windows in space are measured not in minutes, but in moments. That alone makes exposure to vacuum psychologically different from almost any other danger. A fire can spread over time. A flood can rise. A storm can build. A predator can hesitate. Vacuum gives you almost none of that. It does not chase you. It does not roar at you. It simply removes the conditions for survival and waits. And the body is not only losing oxygen now, it is also losing normal fluid balance. Without surrounding pressure, gases dissolved in body fluids may come out of solution. Tissues expand. Edema develops. Circulatory efficiency worsens. This is not identical to decompression sickness in a diver rising too quickly from depth, but it is part of the same broad truth. The body is built to exist within pressure. Change that environment too fast, and internal chemistry stops behaving elegantly. Everything becomes a compromise. Everything becomes less stable. And still, there is no dramatic visual cue from the outside. That is what makes the danger so hard for human intuition to respect. From a distance, a body in vacuum may still look recognizable, human-shaped, intact, floating. But inside that outline, normal life has already come apart. That difference between appearance and reality is one of the most disturbing parts of all. Because in space, death does not always look violent. It looks quiet. A person can look almost untouched, while every life-supporting system is crossing its limit. Now imagine rescue actually happens. Someone reaches you, pulls you back through the hatch. Pressure returns. Air returns. Hands move quickly. Emergency response begins. Would you be saved? Possibly. That depends almost entirely on how long you were exposed. If the exposure was brief enough, seconds, not long tens of seconds, and if repressurization happens fast, survival is possible. Painful, traumatic, but possible. The body may swell and recover, vision may return, circulation may stabilize, consciousness may come back. That sounds hopeful, and in a way, it is. But it also reveals how narrow the line is. Space does not always kill instantly. It gives you a very short margin, a brutal little window. And inside that window, everything depends on timing. This is why astronauts are not only protected by suits, they are protected by layers of planning built around the fact that vacuum exposure is not fantasy. It is physics. Known physics. Tested physics. And the margin for error is almost nothing. That is also why spacewalking feels so unsettling, even when the view is beautiful. Because every successful EVA, every smooth mission outside a spacecraft, is happening right beside an environment that would erase a human body in seconds if the boundary failed. The suit is not convenience. It is the difference between existence and collapse. By now, if exposure continues, consciousness is most likely gone. The body still drifts, still swells, still uses what little oxygen remains, still loses heat slowly to shadow and gains it harshly in sunlight, still moves through silence. But the human experience of the event, the part that thinks, fears, decides, is ending. And that changes the meaning of what comes next. Because the next phase is not about what you feel. It is about what space does after feeling is no longer possible. How long the body continues. What rescue can no longer fix. What irreversible damage actually means in vacuum. And why the line between survivable exposure and permanent loss is shorter than almost anyone imagines. In the next part, we go past consciousness, into the final minutes, the rescue threshold, and the true answer to the question people always ask. Not whether you would explode, but whether there is any version of this that you could come back from. By now, you are no longer inside the human part of the experience. That part ended with consciousness. What remains now is the body in vacuum. And the question people always ask after everything else. Could you come back from this? Not from the fear, not from the memory, not from the trauma, but from the damage itself. Is there any version of exposure to open space, without a suit, where rescue is still possible? The honest answer is yes, but only for a very short time. And even that answer comes with a warning, because survival in vacuum is not a matter of toughness, not courage, not pain tolerance, not willpower. It is timing, only timing. That is the brutal simplicity of it. If you are returned to pressure quickly enough, if oxygen is restored quickly enough, if the body has not crossed too many invisible thresholds, recovery can happen. Not perfectly, not comfortably, but it can happen. And that fact makes space even more disturbing, because it means the difference between survival and death is not dramatic. It is not measured in huge visible events. It is measured in seconds. A body in vacuum does not always look ruined. That is part of the danger. From the outside, the outline can remain human. Arms, legs, face. No explosion, no instant destruction, no obvious cinematic violence. But survival is not decided by appearance. It is decided by oxygen debt, by circulatory collapse, by tissue stress, by whether the brain can be brought back before damage becomes irreversible. And the brain, as always, is where the true limit lives. A few seconds of oxygen loss can be survived. A longer period, and the injury begins to harden into permanence. Neurons do not like interruption. They do not store generous reserves. They function in flow, continuous delivery, continuous support. Break that flow too long, and they begin to die, quietly, microscopically, without asking permission from the rest of the body. That is why rescue in vacuum is really a race against invisible injury. You may still have a heartbeat, circulation may still flicker along, the body may still be warm, but if the brain has gone too long without oxygen, the return is not a return in any meaningful sense. It is only the recovery of organs, without the recovery of the self. That is one of the coldest truths in medicine. Sometimes survival of the body and survival of the person are not the same event, and in vacuum, that gap can open very quickly. Now imagine the rescue is immediate. You are pulled back inside, pressure returns, air floods the compartment, hands move fast, very fast. That first moment of repressurization would not feel magical. It would feel violent in its own way. Not because pressure is harming you, but because systems are slamming back toward conditions they were designed for. Oxygen is forced back into a body that was running out of it. Circulation begins redistributing what little reserve remains. The lungs, if they were not catastrophically damaged, can begin functioning again. The heart may stabilize. The brain may receive just enough support to re-enter awareness. And if that happens, waking up would not feel clean. It would not feel like a movie character opening their eyes and taking one heroic breath. It would be confusion, pain, blur. A body returning from the edge does not come back gracefully. It comes back in fragments. Breath first, then pressure, then partial sensation, then the terrible realization that something happened and you were inside it. Your mouth and eyes may hurt. Your skin may feel stretched, swollen, wrong. Your chest may ache. Vision may be unreliable. Thought may feel delayed. And depending on how long exposure lasted, there may already be injuries you cannot yet understand. That is because rescue is not the same as no damage. A person can survive vacuum exposure and still suffer serious harm. The lungs may be inflamed. The brain may have taken an oxygen hit. The eyes may be injured. Circulation may have been compromised. Fluid shifts may need correction. And the body, even if technically alive, may remain deeply unstable for some time. This is where fantasy often leaves reality behind. In fantasy, space either kills instantly or someone survives almost unharmed. Reality is harsher than both. It gives you a narrow window, then charges interest on every second you stayed beyond it. Now let's follow the darker timeline. the one where rescue is not fast enough. The body drifts longer. Not much longer, just longer. And here the question changes. Not, can you still be saved? But, what becomes irreversible first? Again, the answer leads back to oxygen. Brain tissue begins crossing from dysfunction into injury. The heart, deprived of efficient support, becomes more vulnerable to rhythm instability. Blood pressure control fails. Cellular metabolism, stripped of normal balance, shifts into emergency chemistry. Acid builds, waste accumulates. The body does not stop all at once. It loses coherence. That is a useful word here, coherence. Because life is not just activity, it is organized activity. When oxygen disappears, organization fails before motion does. The heart may still twitch, cells may still perform tiny local processes, but the unified whole, the integrated human system, is unraveling. This is why "still technically alive" can be such a misleading phrase. A body in deep vacuum exposure may still have processes underway, but the architecture of life is already collapsing. The longer that continues, the less there is to bring back. Now let's talk about the final emotional misconception. People imagine space as aggressive, as if it reaches out and attacks. But vacuum does not attack. It withdraws support. That difference matters, because it explains why the death is so eerie. If you drown, water enters. If you burn, heat enters. If you are crushed, force enters. But in vacuum, the fatal mechanism is often absence. No pressure, no breathable air, no medium for sound, no environment for heat balance, no second breath, no negotiation. Space kills by refusing participation. It does nothing for you. And human biology depends on something always being there. Air, pressure, thermal buffering, a world close enough to touch. Remove that, and survival becomes a countdown with no villain, just physics. And that is why exposure to space feels, even in imagination, so psychologically different from almost any earthly danger. There is no animal to fight, no storm to outrun, no enemy to understand, only a perfect emptiness, and the systems inside you noticing that emptiness too late. This is also why astronaut training, spacecraft design, suit engineering, emergency planning, all revolve around margins, tiny margins. Not because engineers are pessimists, but because they know something simple. In space, mistakes are not always corrected by strength. They are corrected by preparation, or not at all. A torn glove, a failed seal, a cracked visor, a pressure leak. Each one sounds technical, abstract, small, but behind each of them is the same truth. The suit is not clothing. The spacecraft is not shelter. They are portable Earth. That is what human spaceflight really is, a way of carrying Earth's conditions with you, because your body cannot make sense of anything else. That idea becomes clearer now. A spacesuit does not just keep you warm, it keeps you pressurized. It gives oxygen, removes carbon dioxide, protects moisture, shields from radiation, supports temperature balance, makes movement possible, keeps your blood where it belongs, your lungs within their safe range, your brain within its narrow margin. The suit is not armor against adventure. It is the only reason adventure is possible at all. Without it, space is not exploration, it is exposure. And exposure is not heroic for very long. That matters for another reason too. Because people often imagine human survival as proof of human dominance, as if going to space means we conquered it. But naked exposure to vacuum reminds us of the opposite. We did not conquer space. We learned how to negotiate with it. Temporarily, carefully, artificially, under layers of engineering, under rules we did not invent. The human body, by itself, has no treaty with vacuum, no adaptation, no hidden emergency mode that makes it a creature of the void. Take away the machines, and we revert instantly to what we really are: land animals, pressure animals, breathing animals, fragile mammals that belong to air. And there is something almost humbling in that. For all our rockets, our stations, our missions, the gap between life and death in space can still be as thin as a membrane, a seal, a valve, a suit layer, one intact system between a functioning mind and total biological collapse. That is not weakness, it is reality. And good science becomes stronger when it respects reality. Now let's go to the final threshold, the point beyond which rescue no longer means return. This is the real edge. Not the first second, not the boiling saliva, not the fading sight, but the moment when time and vacuum has converted a survivable accident into irreversible loss. There is no universal stopwatch for every body in every condition. Biology is not that clean. Temperature matters. Initial health matters. Exact pressure matters. How much air remained matters. What injuries happened in the first second matters. But the broader truth remains. The useful rescue window is terribly short. Very short. And once you pass it, what returns to pressure is no longer a person on the edge of recovery. It is a body carrying injuries too deep to reverse. This is why the idea of being found later in space is not comforting. Later is not the same as rescue. Later is only retrieval. And those two things are separated by just a little time. That is what makes the scenario so haunting. Not that space kills in some spectacular way, but that it draws a line so close to consciousness and then erases the difference between almost saved and gone. Still, there is one final truth worth holding on to, because the question was never only, would you die? It was, what would happen? And the full answer is more subtle than myth. You would not explode. You would not instantly freeze solid. You would not vanish into some dramatic cinematic image. You would lose pressure, lose oxygen, lose clarity, lose control, lose consciousness. And then, depending on time, you might be brought back, or you might not. That is the real answer. Not spectacular, not comforting, but precise. And precision is what makes it frightening, because the body does not fail randomly in space. It fails logically, exactly where physics says it should, exactly where biology cannot continue. That may be the most unsettling part of all. There is no mystery in the mechanism. Only mystery in whether rescue arrives before the mechanism finishes its work. And if it does, what returns may carry the memory of something almost impossible to describe. Not pain exactly, not fear in the ordinary sense, but the experience of having every familiar condition of life removed at once. Air, pressure, sound, orientation, warmth, protection, world, all gone. And that leads to the strongest conclusion this question can offer. The deadliest thing about space is not that it is cold, or dark, or empty. It is that the human body has nowhere inside it to store a spare earth. We survive because the environment around us quietly cooperates. And the moment that cooperation ends, life becomes a countdown. So if you floated in space without a suit, what would happen? For a few seconds, you would remain alive, long enough to be aware that something was deeply wrong, long enough for your body to begin swelling, long enough for oxygen to start running out, long enough for sight, thought, and control to begin slipping away. And after that, everything would depend on time. A few seconds more, and rescue might still matter. A little too long, and nothing could truly bring you back. That is the final answer. Not a scream, not an explosion, not instant ice. Just the most silent kind of biological collapse imaginable. And maybe that is why vacuum remains one of the purest horrors in space. Because it does not look like violence. It looks like nothing. And that nothing is enough. If there is a lesson in all this, it is not only about danger, it is about dependence. Human life feels strong when it is surrounded by the conditions that made it possible. Take those away, and the strength vanishes faster than pride allows us to admit. Which means every astronaut drifting safely outside a spacecraft, every quiet spacewalk, every beautiful image of someone floating over Earth contains a hidden truth. They are not suspended in freedom. They are suspended inside one of the most delicate victories engineering has ever achieved. A thin, private atmosphere, a moving boundary, a borrowed world wrapped around a human body. And beyond that boundary, space is still exactly what it has always been. Silent, beautiful, unforgiving, absolute.